chain reaction. Here it is a continuous chain reaction with help of this fission process. Neutron collides with nucleus. Again, it is splitted. This will be splitted too. This will be splitted, right? Right. Here, the neutrons are needed, yes, sustain a fission chain reaction in which the reactor is critical when neutrons consumed is equal to neutron created. Neutron is critical when neutron is consumed, and equal amount of neutrons will be created automatically. So every neutron does not lead to fission process. Does not lead to fission process. Implication of for reactor design. The reactor design, it is also one of the important phenomena for nuclear power plants. It is based on the choose of fuels with a high probability for fission. It should be fast neutron energy and thermal neutron energy. And second one is select the other material with low probability for absorption. It should be a coolant, okay, and moderator, fuel pin, cladding, and the core structure materials. These things are very important for reactor design. And one more design is important for this. Select the control material with highly probability for absorption. It should be a solid Poisson, boron, and control rods, right? And design geometry of reactor to minimize leakage. In power plant, it's the biggest um, um, negative thing is the leakage of uh, neutrons. It should be avoided with the help of this reflector. Here you can see the next we'll discuss about pressurized water reactor. What is the pressurized water reactor? In a boiling water reactor, here the enriched fuel is used. Here it is, the enriched fuel is used as compared to PWR, pressurized water reactor, right? In which we are using a, here I have shown the abbreviation PWR, right? PWR, here it is a PWR. Yes. So here you can see the pressurized water reactor. Right. Right. Here you can see the pressurized water reactor. In this reactor, we are going to use, here the temperature will be maintained at 325 degrees Celsius, outlet temperature, and greater than 100,000 megavolt. Here it is produced, right? The main thing is soluble Poisson and chemistry adjustment in coolant water. Here it is used. Here, this is the simple, most commonly used design. This is the most commonly used design, in which we have the reactor vessel and the control rods. Here the steam generator, right? Here is the steam generator. Here the pressurized water reactor, it is in a simplest form. Here it is a simplest form. Actually, it is a light water cooled and moderated thermal reactor. Actually, here it is having an unusual core design. Here it is having an unusual core design. The main principal parts of this cold reactor is pressure vessels, reactor thermal shield, fuel elements, control rods, reactor containments, okay, and the reactor pressurizer. Actually, in this pressure reactor, there is a two circuits, okay, two circuits of water, okay. The one is a primary circuit, which is passes through the fuels, core, and is radioactive, This primary circuit then produce a steam, and it is sent to the secondary circuit with consist of heat exchanger, which is act as a heat exchanger, like, and as such a steam in the turbine is not a radioactive and it need not to shielded. It is not need not to shielded. Here the pressure in the primary circuit should be high so that the boiling of water takes place at high pressure, so that the boiling of water takes place at high pressure. This is the main advantage of this system. And here the pressure tank keeps the water is at about 100 kg per centimeter square. Here it is maintained at 100 kg per centimeter square. Right. This is a simple schematic view of pressurized reactor. Next is the boiling water reactor. Sorry. Here the boiling water reactor. In this reactor, here it is a enriched fuel is used. When compared with the PWR, I mean pressurized water reactor, here the arrangement of BWR is very simple. In this power plant, it's very safely operated using the natural convectional within the core and forced circulation. And forced circulation, here it is shown in figure. Right, here it is forced circulation. Here we are going to use it, and the main thing for this reactor is park load operation of this turbine. Here the park load, here the park load of load operation of the turbine. Some steam is bypassed. Here it is some steam. Okay, here the some steam is bypassed. Okay, this is the main difference between PWR and PWR. Okay. Here, the main advantage of this BWR is the heat exchanger circuit is eliminated, and consequently, there is a gain in thermal efficiency. With the help of this, with avoiding this extra circuit, we can increase the thermal efficiency, and also we can get the gain in cost. And the second one is that there is a use of lower pressure vessel for the reactor, which further reduces the cost and simplifies the containment problems. Okay, right. And as well as the metal temperature remains low for given output conditions. This is the main advantage of this BWR. Discuss here. This is the Kandu. This is the oldest technique, I think. This Kandu is a thermal nuclear power plant reactor in which heavy water, 99.8% deuterium oxide, D2O. Okay, D2O is a moderator material, and it is a coolant as well as the neutron reflector. As well as neutron is a reflector. Here it is a moderator material will be deuterium oxide. I mean D2O. D2O it is used, right? This reactor was developed in Canada and it is being extensively used in this company. Okay. This type of reactor generally consists of natural uranium 0.7%. Okay, 0.7% U-235 uranium is used as a fuel, and the heavy water as a moderator. Here it is heavy water as a moderator used for this system. Here it is the same procedure. The Kandu, here it is a different basically form light water reactor. Here it is a basically forms light water reactor. In that the latter, the some water serve as both moderator and coolant. Some water serves as both moderator and coolant, right? Whereas in the Kandu reactor, the moderator and the coolant are kept separated. In the Kandu reactor, the moderator and the coolant are kept separated. Okay, this is the main difference. And the Kandu reactor vessel, which contains the relatively cool heavy water moderator, it does not have to withstand a high pressure. Okay, only the heavy water coolant circuit has to be pressurized in this Kandu reactor. Here you can see in this type I have mentioned a 0.7% of U-35 heat is used for the fuel. This type of reactor first designed and developed in Canada. Here the main advantage of this system is, the major advantage of this system reactor is that fuel need not be enriched, but in case of BWR should be enriched fuels, but in this it's not enriched fuels. Here the reactor vessel may be built in a withstand lower pressure, therefore the cost of the vessel is less. Here the cost of the vessel is less. Here no control dots are required, therefore the control is much easier than other types. Here the moderator can be kept at a lower temperature, which increase in effectiveness in slowing down the neutrons. In heavy water being a very good moderator, this type of reactor has higher multiplication factors and low fuel consumptions. And finally, the shorter period is required for this site constructions compared with PWR and BWR. Here, more advantages are there. Roughly third the reason operating in the United States are boiling water reactors. Here, BWR or heavy water reactors steam directly inside the reactor vessels. Water is pumped up through the reactor core and heated by fission. Right here, the last one, the unused steam is condensed back to water and reused in the heating process. Next, let's see the next let's see gas cooled fast reactor. In this gas cooled reactor, here we are going to using a helium as a coolant. Here the output temperature of the coolant is 850 degrees. Here we are going to using direct gas turbine conversion cycle around 48% efficiency. Here megavolt MH 600 MW. Here it is going to produce several fuel option and core configuration will be extra advantage for this gas cooled reactor. Here the benefit of this system is waste minimization and efficient use in uranium as a resources. In supercritical water cooled reactor is in which the main character of this system is water coolant as supercritical condition. Here it is a 550 degree Celsius output temperature. Okay. Here 1700 MW. Here it is we are going to produce, and the pressure of this system is greater than 20 megapascal. Here it is simplified balance of power plants. Here benefits of this system is efficiency nearly 45% with excellent economics, and main advantage of this system is thermal or fast neutron spectrum.